You can't tell what is W equal to. Yes, W is equal. That is different. F is equal. F into S is equal to B.
W into B.
Yes. Into Q. Okay. So W is equal to V Q. What is W?
Work done.
Work done. V potential difference. And Q,
Electric charge.
what is it? Bulb. Aya, bulb aya. What is it? What is Q? Correct. Is there any other equation that you have learned about Q?
Q is equal to 2C.
Eh?
Q is equal to 2C.
Q is equal to? I told you. I into T. I've told you simple methods of remembering this formula. Q is equal to I T. What does it mean? Width. I told you to remember Q is equal to I into T. What is Q?
Charge.
Charge. I? T? Time. So we have already learned these formulas. Yes or no? We have also learned something about resistors which are in combination of RS and RP. What does RS stand for? What will be the formula?
R1 plus R2 plus R2.
Yes, R1 plus R2, etc. etc. If I'm talking about RP, what does it mean?
1 upon R1 plus 1 by R2.
Okay, so it is the reciprocal. Should I write it as RP is equal to 1 upon
1
R1?
by R2.
Yes, it is reciprocal of the resistors which are connected in parallel. Okay, so we have got a whole lot of formulas which we have already learned. In the last page, I have already started. I've asked you to write down all the formulas, and I've also given you a table regarding what are the terms and what are the units, okay, and how we are going to write down. Is that okay or no? It's high time you know, yes. Okay, so we have completed with the first part of the lesson. Now, what are we going to do is the second part of the lesson, which is talking about the heating effect of electric current. Okay, now let's try to understand what is meant by the heating effect. Basically, when you look at all the formulas, what we have learned is whenever we have a conducting wire, imagine that this is a copper wire, okay, and when we are connecting it to the battery or to a source of current, we know that it is a good conductor. So when we are talking about a good conductor, what does it mean? It is allowing the charges to move through. So what are these charges called? What are these charges that we are talking about? The electrons, the negative charges. Okay, so because of the movement, we know that it is a good conductor. But there are some of the conductors which we know may not be a very good conductor of electrons. Maybe the electrons are not moving easily. Okay, because there could be some kind of a hindrance where it is not moving properly. That means to say that the resistance may be slightly different. In this case, in the first case, I said the electrons are moving very, very easily. Therefore, the current is flowing very easily, and therefore we say it is a good conductor. What does it tell us about the resistance?
Very
of the
less.
first case? Yes, resistance is very less. So it has got a very low resistance. Therefore, all these electrons are moving very easily. Did you understand? Remember what I told you about a tunnel and people moving, etc. Now let us look at the next case. Suppose there is some kind of an obstruction here. Okay, what happens to the electrons which are flowing? They are having some kind of an obstruction. It's not moving easily. So it will go and collide with the other atoms. Maybe it is going to colliding with the other ions. So in this case, what happens? This kinetic energy is increasing. Now this increase in the kinetic energy is what is transformed into heat. Okay. Remember that heat is also a form of energy. So what is happening here in this particular case? What type of energy is getting converted into heat energy? It is what?
Kinetic.
Electrical energy, which is getting converted into heat energy. But do we want our wires to get heated up? No. So what type of wires are we going to use? The first type. Okay. The first type of wires, like for example, we may use a copper wire, we may use let us say an aluminum wire. These are all very good conductors. Okay. When do we require some kind of a wire which is getting heated up? And obviously we require heat energy. Okay. For example, at home, we are having a bread toaster. The moment you switch on the bread toaster, you will find that those coils are getting heated up. It becomes red hot. Have you noticed it? It becomes red hot. That means to say you're supplying energy, you're supplying the current, and at the same time the filament is getting hot. So we are using such type of materials which has got a considerable amount of resistance. Because there is a resistance for the movement of the electrons, you find that there is an obstruction. There is some kind of collision of the electrons taking place, and which is getting translated into kinetic energy, which later on gets converted into heat energy. Okay? In some of the houses, probably you have been using an immersion heater. Okay? Maybe you are using an oven. Okay? For all such purposes, you require heat energy. Did you follow? Can we have heat energy when we are using a coil of, let us say, copper or aluminum? No, it does not get heated. These wires are not getting heated. There's minimal heating which is taking place. When do we require heat energy? Is obviously when you need to utilize that heat energy for any type of a purpose. Okay. Some of you may be already familiar with these type of bulbs. Okay. I'm not talking about LED bulbs. I'm talking about an incandescent bulb. What bulb? It is an incandescent bulb. Now, if you notice very carefully, you have a coil like that inside. Okay, so that is your tungsten filament. So such type of filaments are used because when the current passes through, this tungsten filament becomes red hot. Okay, it becomes hot and therefore it is able to emit light. Okay. So also in this particular purpose, you have got your electrical energy which is getting converted into light energy. Have you followed? Can we use copper or aluminium here? No. So we use another type of a wire. So what wire is that? This is called tungsten wire. Why? Because the melting point is very, very high. Have you followed? The melting point is very high. So even though you keep it on for some time, even if you keep it on for 5 or 10 minutes, switch it off and touch the bulb. I don't know whether you've done it or not. The moment you touch this, you know it is hot. Okay, so that means to say the filament has got heated up and therefore it is able to emit light. Is that okay? Have you followed? So what are we making use of? We are making use of this resistance. There's a considerable amount of resistance by which the element or the filament is getting heated up. Did you understand now? Sorry, yes, you have a doubt. You have a doubt. Did you understand? Now the second part of the chapter, we are making use of what we have already learned here. Is that okay? I'm trying to find out how we can actually make use of this for our advantage. Okay, we are talking about the power of an appliance, we are talking about the heating effect, etc. Is that okay? Coming back once again. There's another formula which we have already learned, apart from Ohm's law, etc. etc. So first, Ohm's law, second was this, third, fourth, fifth. R is always directly proportional to something else. Tell me in terms of length, tell me in terms of cross-sectional area.
Directly proportional to length and inversely proportional to area.
Very good. Correct? Yes. So what did we learn? R is directly proportional to length. Greater the length, what happens to the resistance?
Higher the resistance.
The resistance is also higher. Okay? And we have also seen that it is inversely proportional to cross-sectional area. You remember the diagram that I gave you? Tunnel, if the tunnel is big, the people can move in fast. But if the tunnel is small, very narrow, cross-sectionally very small, then there's going to be an obstruction. Okay. So using this, what was the formula that we have learned?
R is equal to I.
What is that?
R is equal to rho L by
Rho. Okay. So we have seen that R is equal to rho L upon A. What is rho?
resistivity.
Resistivity. So that is your other formula that we have learned. Okay. Now I'm asking you a question. Using this and using R, coming back to the bulk here. See how we are trying to make use of what we have learned there and talking about our next section. Now pay attention to the question that I'm going to ask you. We said that I want a heating effect. That means we are making use of resistance. We want a higher resistance. How can the resistance of this tungsten wire be increased?
Increasing the length and decreasing the of the cross.
Yes, Kaushik, what is your answer? Right? Right?
Coiling.
Coiling. So what are we doing? With
Increasing
respect
the
to the length?
resistance. Decrease.
Very good. Your answer is correct. That means you're increasing the length. So what are we saying here? You find that the filament is coiled like that. So we are increasing the length. R is directly proportional to L. So if you are increasing the length, you are increasing the resistance. What about A? Very thin wire. Okay, you find that it is so fine. If you are having a bulb, make use of it. See how those coils are very thin. So what are we doing? We are reducing the area of cross section. By decreasing that, obviously R is going to increase. Is that okay? So if I'm giving you a question, right, as to how this bulb works, what are we going to say? We are using the principle of resistance by increasing the length and decreasing the area of cross section. You are increasing the resistance. And by increasing the resistance, obviously more heating effect is produced. And the bulb is working on the heating effect of electric current. Is that okay? Is that okay? See how we are connecting. You will not have an answer like in history books or something of that sort, from this para to this para. No. We have to learn to connect whatever we have learned. Is that okay? Yes or no?
Yes.
Come to page number. I hope everybody has got all those formulas now. You have written down in one place or no? Come to page number 188. Heating effect of electric current. Okay, so everybody is ready with that? Okay. Should be done. This is this. So, interesting. It's not nice for me to, pull you up like this. Hello? You're all old enough. No longer babies. But if you feel that you want to behave like a baby, please go back to your primary section. If you are sitting in my class, be responsible. I'm not in a habit of pulling you up like this. I think it's high time that you are responsible. Yes? Yes or no? Will you read heating effect? Read it very slowly, and I want everybody to be ready with your pencil because we are going to underline a few important points. There. You know that a battery or a cell,
You know that the battery or a cell is a source of electrical energy. The chemical reaction with the cell generates substantial effect between two terminals.
pay attention to the words because I'm going to ask you a couple of questions.
That sets the electrons in motion. also seen in section 11.2 that to maintain the current, the source has to keep spending its energy. Where does this energy go? A part of the source energy maintain the current may be contributed to useful work like regulating the blades of an electric fan. The rest of the source energy may be expended in heat to raise the temperature of gadgets. We often observe this with our everyday life. For example, an electric fan becomes warm if used continuously for a longer time, etc. On the other hand, if the electric circuit is purely resistive, that is a configuration of resistors only connected to a battery, the source energy continually gets
Dissipated.
dissipated entirely in the form of heat. This is known as the heating effect of electric current.
Underline heating effect of electric current.
This effect is utilized in devices such as electric heater, electric iron, etc.
So what are the devices which is making use of the heating effect? You have your iron, okay, for ironing clothes, maybe toaster, maybe heater, okay, maybe your water heating source, okay. All these are making use of heating effect of, okay. Did you understand? Now the question is, look at me. Suppose this is a battery, a cell, simple. You have a positive terminal and a negative terminal. What is present inside by which it is driving the electrons? What is getting converted into electrical energy? Chemical energy. You know that, okay? Because there are chemicals inside the cell, so obviously that is getting converted into electrical energy. So, what is the function of the cell? I've asked you before. What is the function of the cell?
To maintain the flow of electricity.
Yes,
Yeah.
reactions are going on. What is the function of the cell?
Maintain the flow of electrons.
Yes. What is your answer? No. Yeah, correct. Chemical energy is getting converted into electrical energy. But what is it? Why is that this is required?
Driving a passive.
To provide energy. What should be maintained between the two ends? What should be maintained between the two ends?
Flow of electrons.
So what is required here to be maintained between the two ends? What is it?
Potential.
Yes, your answer is correct. Okay. So what is the function of the cell? The function of the cell is to maintain a potential difference. If there is a potential difference, only then there will be a flow of electrons. Okay, na? All of you remember that? There should be a difference of the potential energy, otherwise there is no flow of electrons. If this potential and this potential is the same, will you have a flow of electrons taking place? No. Did you understand now? Yeah? So the function of the cell is to maintain a potential difference. Only then there will be a flow of electrons, or there will be a flow of charges. Have you followed? Yes or no? Very good. Come on now. So the first part of it you have seen. Okay, so now basically we are talking about the heating effect, and we also see okay, how can we actually find out what is the power of a gadget? Okay, suppose you look at the bulb. Many times if you look at the bulb, there's something like a 40-watt bulb, or there may be a 100-watt bulb. Correct? What does the W stand for? Watt. That is the unit of power. Okay, so it tells us that every gadget has got some power. So find out now what is power. Okay, we come back again to our 9th standard. We have already seen something about work. Okay, and we have seen, let us say, Suppose there is a go down or whatever it is, and there are some 50 bags which have to be transported to a particular place. Okay. Now I have person A and person B. Both of them are given the job of transferring 50 bags to a particular go down. Suppose this person is taking only half an hour, but this person is taking 45 minutes to transfer. Who is more powerful? Hello, good morning. So we have seen that person A is more powerful as when compared to person B. How do we know he is more powerful?
He takes less time.
He is taking less time. So to do the same amount of work, we are using the concept of time. We are comparing it with time. So we know that person is more powerful, or we can talk about power, which is equal to work upon time.
More work in less time.
It is the same amount of work, not the more work. Work is the same in both the cases. He is also transferring 50 bags, he is also transferring 50 bags. Work part of it is the same. Only the time taken is less, and therefore the power is more. Is that okay? Look at the formula itself. If there is less time, it is in denominator. If the denominator is less, then P will become more. Correct? If P is more, if the denominator is more, then obviously P is going to be less. Is that okay? So it is the same concept that we are going to use. Now we are talking in terms of power, and the work done is in terms of the electrical work. We are not talking about the mechanical work or the physical work. Okay? So I'm maintaining this formula and then going back again to another concept. Sorry. Okay. Now we'd like to see something about the work done. Suppose I want my machine to work, washing machine. What should we do? What should I supply?
Electrical
Correct. I have to supply the electric current, right? Electric current is nothing but energy. Is that okay? Have you all followed? So if I supply electrical energy, I know that work is being done. Correct? So for work to be done, there has to be a supply of energy. In a physical body, we have to have food, right? It is the food which is getting converted into ATP, and it is the ATP which is utilized for various type of, whether it is the biochemical changes taking place or for any type of a physical work. Same concept. Work has to be performed, we have to supply energy. So you realize that the units for electrical energy, work done, energy and work will be the same. What is the unit?
They choose.
Very good. If for work it is joule, for energy also it is joule. We are not talking about power. For power it is what? Okay, so there is another unit which I have already put up. It is in watt. Have you followed? Will you remember this? So you have got work and energy which are very closely related, and obviously the unit will be the same. Right? Now we come to the next paragraph. We have seen that power is equal to work upon time. Now here we have also seen that work is nothing but we can talk in terms of energy also. Okay. Now what type of energy? We have said it is the work done. We go back here. Where do we have? W is equal to V into Q. So I substitute the same thing. Power is equal to V into Q, which is your work done upon time. Okay? Is that okay? Now I want you to look at this part.
I.
What is Q upon T?
I.
Q upon T will be I. Right? So I can say P is equal to V, Q upon T is equal to I. Therefore, power of any gadget can also be given as the potential difference times the current drawn by that gadget. Have you followed? Take it up. Heading will be heating effect of electric current. Heating effect of electric current. Sure. Yes. Okay, we'll be constantly making use of all those formulas. See how we have utilized that formula to come to another one. We do not know anything about the resistance, correct? But just by knowing what is the voltage which is supplied, which is going to be usually 220 volts, that is the voltage supplied. And I, of course, we know how much the current is drawn from a particular gadget. Is that okay? Right? Yeah. Done? Okay. Look at the second paragraph in your textbook. Abhishek, read second paragraph. Consider a current.
Consider a current I flowing through a resistor of resistance R. Let which a charge let the potential difference across it be 5.
Yeah, potential difference V.
Let T be the time during which the charge Q flows across. The work done in moving the charge Q to a potential difference V is V into Q. Therefore, the source must supply energy equal to VQ in time T. Hence, the power input to the circuit by the source is P is equal to V into Q upon T, which is equal to V into I.
Did you understand how you got V into I? Okay. We have utilized all those formulas that we have already learned in the previous section. V, W is equal to, of course, the work done, and that is equal to V upon T. Substituting this, we are getting it as I. Is that okay? Now, we have also said that work is nothing but the energy which is supplied. Okay. I come back again to this equation. P is equal to work upon time. Okay. Suppose I rearrange and I say W is equal to what will I get?
P
P into T. Okay, P times T. But what is this?
energy, heat,
It is nothing but the work done. And work done is in the form of
and
energy. Which energy are we talking
heat
about?
energy.
It is nothing but your heat energy, because now we are talking about the heating effect of current. Okay? So this is your heat energy. So did you see that heat energy is given as P into T? What is P here?
Work done upon time.
P is equal to what?
Power.
Power. It is power. Power into time. How will you remember this? It's once again a very, very simple way to remember. You have your PT classes in school.
Yes.
What is PT? Your physical education, okay, where you run about, do your sports, whatever it is. Aren't you expending your energy? Yes. Easy for you to remember. You are expending your energy when you're going for your PT classes. So this is an easy method for you to remember. Energy is equal to PT. But your energy, which energy are we talking about?
Heat energy.
It is nothing but your heat energy. Is that okay? Will you try to remember it that way? It's a very simple thing, but we are going to utilize this in various ways once again. Correct? Look at the next paragraph. Or the energy supplied to the circuit by the source in time is equal to P into T. This is what we have done. What are we talking about? Energy which is supplied. Okay? Or we are supplying some kind of an electrical energy which is getting converted into heat energy, which is equal to P into T. That is equal to VIT. How did we get which is equal to VIT? What is P?
Yeah.
We have already seen that it is equal to VI. Okay? So your heat energy can also be written as V into I, because your P is nothing but V into I. So it is equal to V. So your heat energy can also be given as VIT. Take care of
What is the unit of
heat. What did I tell you? Heat energy, energy.
uh,
Okay, so that's another formula that you will remember now. On this side, for part 2, you have another set of equations. We have seen power is equal to work upon time. Okay, the next thing that we have said is H is equal to V into I into T. We have also seen this where W, which is the work done, is nothing but T into T. This is the same thing. These two are the same.
what we find.
Is that okay? So we can definitely calculate how much of heat is going to be produced by any particular gadget. If I know what is the voltage and if I know what is I, which is the current drawn by a particular instrument, and T, which is your time. Here, here. Okay. Look at this. Everybody, please look here. What does it tell us? Is it directly proportional to or inversely proportional? Higher the voltage, higher the heat produced. More the current, more the heat is produced. If you supply it for more time, if you keep the gadget on for more time, more heat is produced. Okay? So all the three of them are directly proportional. Is that okay? Have you all followed? So look at the last paragraph here. This energy, did you get? Did you get that? Second line there. This energy gets dissipated in the resistor as heat. Did you underline it in your textbook? Last paragraph on page number 188. Okay. Thus, for a steady current I, the amount of heat which is produced in time t is equal to VIT. So that is another formula that I have written here. Is that okay? Now, coming back here. I have this, let me call it as sub-equation number 1. So I have H is equal to V into I into T. Okay. Can we make use of Ohm's law? What is Ohm's law? V is equal to IR. So instead of V, I can use I into R times I times T, which is equal to H is equal to I square RT. Okay. So H is equal to I square RT. So that is your another equation which I can use. H can also be written as I square R into T. Take down this. So when can we use this equation? When we don't know anything about the potential difference. I do not know what is the potential difference. If they have not given me anything about the potential difference, but I know what is the time, I know the resistance, and I know the current, that is when I can make use of this equation. Okay, so this happens to be your second equation. Once again, we make use of this. What is I here? Using this equation, can you find out what is I? What? What is I here?
V by R.
I is equal to what? Huh? Suppose I'm using I is equal to V upon R. and I'm going to substitute here. Do that and show it to everybody in your notebook. Substitute, no talking. Substitute it here and do it.
V square P.
I said no talking, do it in your book and show. I'm coming around to check. Very good. Go ahead, sir. Yeah, I can do it. Correct.
Yes.
Yes, correct.
सही है ना सही है
Yeah, each one and each of the arts was so this is arts where you can learn the arts very What is the answer?
V square upon R.
Okay, so what did we do? We have substituted as V upon R. Whole thing is, that's whole square. Okay, R, T. So one of the R's is getting cancelled, therefore H is equal to V square T upon R. So that is your third equation which you can utilize. Okay, see how we are using these set of equations for finding out, okay, different other, yes.
V square P upon like whole R.
Yes, obviously, upon R. Now where can we use this particular, the third equation? Look at the board. When we do not know the current, when potential difference is known, time is known, resistance is known, but I do not know anything about the current, that is when you can utilize this particular formula. So how many formulas have we learned today? We have already done 3 formula. H is equal to I square RT, H is equal to V square T upon R, and the other one, of course, I have already written it. So this is your 1, 2, and that is your 3. Have you followed? Okay. So when we talk about Joule's law, what is Joule's law? Joule, of course, is, you must have heard,
Yes.
scientist Joule. He has performed a number of experiments. Okay. And once again, it is put forward in the form of a law because it tells us H is equal to I square RT. If we are having a steady current of I, what does it tell us? That the heat produced is directly proportional to I. Heat produced is directly proportional to R. What is R? Resistance. The greater the resistance of the coil, the greater is the heat produced. Also is directly proportional to T. Okay, greater the time, obviously so much heat is produced. So, is that okay? Clear? Okay. Look at the next page. Applying Ohm's law, we get H is equal to I square RT. Underline or put a tick mark in your book. Which page are we talking? But this is known as Joule's law of heating. The law implies that heat produced in a resistor is, the first thing is directly proportional to the square of the current. Why square? Because you know there is a square here. Kaushik, did you understand? Don't write it as directly proportional to current. because there's a square that is proportional to the square of the current. Second thing is directly proportional to the resistance. Third is directly proportional for the time. All of you will please take it down in your notebooks. Statement of Joule's law. Write it down properly. I know it is there in the textbook, but when you are writing it down, pay attention to the words and write it properly. And all those points, point number 1, 2, 3, write it one below the other. Don't write it in a paragraph.
I will just have to write the words, right?
Statement of Joule's law. How will you start? Suppose I'm asking you in an
Law
exam.
states that
Obviously.
heat produced by a wire is directly produced. Heat produced by a wire.
Directly from the textbook.
So ma'am, in that we won't be like mentioning heat.
He produces
No,
it.
resistor. अच्छा हाँ heat produced बोल दी.
All those 3 points. Write it neatly. Raj. Write it. I'll ask one of you to stand up and tell me the law. So when you're writing it down, don't scribble. Learn it up and write. Okay. कहाँ से लिख रहे हैं? Where are you writing? Right. Kaushik finished? Let me see your book. This is your physics book or the book? Where have you written all your formulas? Everybody has made a note of all the formulas?
Yes, ma'am.
This is क्यों नहीं लिखा? Ohm meter and E square E upon R. E square E, don't consider it I. That doesn't want to be. Have you written? Show me. This is done or no? You have taken down everything. Understood? Is it easy for you to remember the law now? If you remember the formula, it becomes very easy for you to understand and put it down in the form of a statement. Who can tell me the law? Gufran will tell. Gufran after. I'll ask him in the last. Anyone else? Rujin, can you tell me the law? What is Newton's law? Abhi likha na? Try to remember the formula. H is equal to I square RT. Yeah. Learn it up. Learn it up, everyone. Okay, I'll start it.
Joule's law states that the heat produced in a resistor is directly proportional to the square of the electric current that is produced in the resistor. It is directly proportional to the resistor resistance.
And also third point, with respect to
Directly proportional to the
time.
time.
Okay, fine, that's all. Okay, so H is equal to I square RT. Okay, let's do example 11.10 in your textbook. Don't look at the solved expression. Let's try to do it on our own. An electric iron consumes. So this is an example sum. What is given to us, what we have to find, and which formula are we using. All of you please cover your textbook. Cover that part where the working is done. Don't look at it. You do it on your own. An electric current consumes energy at the rate of 840 W. Okay. Heating is at a maximum rate and 360 W when the heating is at minimum. This is for maximum. And the voltage which is given is 220 volts. What are the current and the resistance in each case? I have to find out what is the current and resistance. In each case, so there is case number 1 and there's a case number 2.
How can this heating be taken as part of it?
Now let's try to understand. Okay, all of you please look at the board. They are given 840 W.
Wow.
What does it tell us? Is
Is
it energy or is it power?
Power.
How can you make out?
Because what is
What is the unit of power? Okay, so this is your SI unit of power. So even though they have given the energy supplied, etc., don't get confused. What will you write it there as? Yes. So what alphabet will you use?
P.
Very good. So we know that this is also P, okay, and this is also P, power. Okay. What is 220 V? Potential difference. So what alphabet will you use? V. What is the alphabet for current? I. Everybody knows it or no?
Yes.
Resistance is what? R. How can we find out I?
P is equal to W upon
P is equal to?
W
I've
upon
given something. I've given something.
P equal to VI.
Yes. P is equal to V into I. So the first formula we are going to use, P is equal to V into I. If I have to find out I, I'm going to rearrange this. Now what will it be?
I is equal to V upon P.
P upon
V.
Okay. Now your answer will be in what units?
Ampere.
I is current.
Ampere.
So your listing answer will be in amperes. Current
Electric charge is
Q. Never mind, first you think of yourself. He can take care of himself. I'm very confident about him. I'm scared about you.
And for this is for the first case. Right?
Yes, for both the cases you have to work out. For the first case you work out, same formula you use it for the second case also. You will have decimals given, you have to work out.
3.8.
And I want all working to be done on the same page. 3 point
3.81
3 point. Rujul, on the page, I want to see everybody do the working. I want to see your long division there.
3.81.
Okay. See the next one. See the next digit. Then you can correct it up to the second digit.
I got 3.82.
3.82 नहीं आएगा, 3.81 something will come.
3.81 recurring.
Okay, so in the first case, okay,
So we have to the approx sign over there.
ठीक है, up to the correct it to the first decimal place. In the first case, the current that we have found is 3.82, na? That's what you said?
Yes.
8182. Okay, we'll accept it. Correct it to the first decimal place. I want you to find out in the second case also.
Done. 1.64 ampere.
Everyone. I'm coming around now. I want to see all working to be done there.
No, 1.63. 1.63. No, 1.63. So 3.8 is 1 half. 1.63. 1.63.
Another digit.
I'm reading it. My 1.66.
मुझे 3.82.
1.63. 4.
Why are you shouting? Come now. One more. Ashita got it or no? Got it? So in the second case, how much is your current?
1.63.
Okay, 1.63. Once again, it is current, therefore your answer is in amperes. So if you look at the problem that they've asked you, you have found out the current in both the cases. Okay? What is the next thing that we have to find out? We have to find out resistance. How will you find resistance? Look at the formulas.
V equal to I.
Once again, our Ohm's law is going to be very useful. Okay, I have to find out resistance here. So resistance is equal to V upon I. I know the voltage, I know the current, and therefore I can find out what is the resistance. For both the cases. Okay, for both the cases, you have to find out what is the resistance. So for resistance now, R is equal to V upon I. V is already known to us, which is equal to 220. I is known to us. In both the cases, we have found out. Therefore, you're going to calculate.
And we have to find the resistance for both cases or just a second.
Look at the question.
Each.
A little bit of math here. And unfortunately, it is in decimal point, so you have to do it. See what formula we do. Ohm's law में क्या है? V is equal to IR. Okay, we are finding out R is equal to V upon I. V is already given to us, right? It is 220 divided by. Raj, on your own, no discussion. Think in your mind. Think in your mind. Both the cases. Check your answers. Has anybody got R in the first case?
Yes, 57.6.
6.
6. No,
6.
They're correct.
See here. We have found out current in both the cases. This you have done. Next thing is I have to find out resistance. Okay, resistance क्या है? Once again we are going back to Ohm's law. V is equal to IR. Reshuffle that you will get R is equal to V upon I. V is already known to us, no? V and I current हम गया 3.8. So how much is R? R you are going to write it as 220 volts divided by the current that you have, that is equal to 3.8. Okay, shift by 2 decimal places into 100 times 100. Okay, so it is 220 divided by 382. Teachers will not give you any marks if you are doing it in your rough page. Even in the board examination, I am telling you, if your rough work is done somewhere else, they will not give you any marks. Always draw a rough corner. As long as you are such type of things. This is not mental class, right?
If I just take one decimal, I'm getting like a difference. Because I got 3.85.
Okay. So okay. What was R in the first case? How much is R in the first case?
7.6.
57.6. Okay. What is your unit? Abhishek, done the first one and the second one. Okay. So resistance, so many ohms. And the second one? What is R in the second case? How much is it? Did you get it as 134?
Yes, ma'am.
Yes, ma'am.
134.
How much?
1 pack.
Did you, can I have a look at your working? Done? Very good. How much is it? So many ohms. Now, put your pens down. Everyone. I want you to look at the answers that you have got.
And the resistance is more than the current flowing.
Exactly. So this will give you an idea regarding current and resistance. Okay. Here the resistance is more. 134, resistance is more. Therefore the current is less. Your resistance is less. Therefore the current is less. Did you understand? Therefore, by doing such type of numericals, you will also reinforce your theory. Yeah. It's lengthy, not tricky. It's simple division. Only thing is it's lengthy. That's all. Write your observation there. Sometimes they may ask you, give it in the form of not only answers. Gufran?
Is divided into decimal places.
Yeah. Correct. Shh, shh. Everybody right now. What is your observation? Okay, by doing this problem, you will observe that if resistance is more, the current flowing will be less. Okay, let's do the next example sum. Once again, try not to look at the answers. Next one. 100 joules. 100 J is given. What is J? Okay, of heat is produced. Of heat is produced each second. So time is also known in a 4 ohm resistance. Okay. Find the potential difference. If you read that very carefully, find potential difference.
Resistance, right? For resistance,
Abhishek,
P by R.
please don't go back into the excited state, come back to the ground level. Don't be an electron shooting up. Okay, now what is the information that is given? Neil, can you understand? This is what is given in the sum, but how do I know what alphabet to write, etc., etc.? What? Neil, what is this 100J? What is 100? J is definitely, yeah, the heat produced. This one? Alphabet? Very good. Time? Each second is given. We have to find out the potential difference. For this is what? V. So V is equal to? Use so many formulas are given you here. See this?
No, but you can use B square P by R. I is not given.
There are so many things that you can manipulate here. It's not there, so you pick and choose where I is not there. Veera, we know now.
I'm using bad words.
Or you want to concentrate what is happening?
Ma'am, how did the root come in the formula?
That's fine.
I can use a direct formula here. They given you two steps.
But voltage cannot be.
Of course, this also that. Q.
Okay. Now those of you who are finished, look at your textbook. They have used a two-step one. In the first step, they've used H is equal to I square RT. They have found out I. Then using I, they have substituted in, in Ohm's law. V is equal to I.
Directly write that.
Directly, you can also. You can use the direct formula also. No problem. We know H, okay, we know time, and we know we have to find out the potential difference we can choose.
B square.
Either which way you can do. See the last one. Look at the last one. V square. V square is equal to H into R upon T. So whatever answer you get, root of that will be your potential difference.
When P.
Okay. Or the other way of doing it is you find out I, using I, use Ohm's law, and you can find it. Either which way is correct. Finish? Okay. Go to the next page. Let him do. Leave him alone. Let him do. He'll understand. Well, finish. You are talking to the team. Why are you disturbing him? Huh? Why do you do Sharaf? I've already told you what has to be done. You want to handle potential. So we don't know what is potential. So we square is equal to H into R upon T. Find out what is that value. Then you say under root of it. That is a direct method. Look at the text I have given you. First find out I. Then using the triangle blocks. Okay, we are on page number 190. 190. First one. Ready? First question.
Yes.
Rufran, first question.
Why does the cord of an electric heater not glow while the heating element does?
There are two things that they have mentioned. What are the two appliances? One is an electric heater and the other one is heating element. Why does the cord of the electric heater not glow while the heating element itself glows?
Because the cord is made of.
Did you understand?
Is made
Suppose
of-
and this is an electric heater. Look at me, everyone. It may be an electric toaster, it may be an electric heater, whatever. There's a cord which is connecting to the plug there. Which is becoming hot, this is becoming hot. The wire is not becoming hot.
It's made out of conductor.
So there are two things that we are using.
The heat energy is transferred.
No, it's like a heat.
It's
It's
a
a
conductance.
Copper?
No,
This is definitely a wire. Insulated, correct. But why is the cord? Yes. Yes. So this wire which is connected to the plug obviously has to conduct electricity. Therefore, the resistance has to be low. Okay, so it is not getting heated. Whereas the element which is kept here, this has to become red hot. So it is made up of a different wire. Which wire is it? What will it have?
It will have
It
more
will
data.
have higher resistance. Did you understand? So the heating element is made up of a wire having a higher resistance, whereas the cord itself is made up of another wire which has got low resistance. Make a note of it quickly. Did you understand? This is your heating element for ironing clothes or whatever it is. This is becoming hot. Okay, not the wire. So there are two special type of wires which we have to use. क्या हो गया? Don't know because you're busy also. And I will not leave the class until you finish. If the bell goes, I'm not going to allow you to go around. Unless the answer is there in your notebook. Hurry up. Don't mess around with me. No. Twice I've already told you. Shh. Not once, 3 times.
So the cord
is the cord inside which flows? Or the cord is the
Cord is that wire.
cord is which is connected the go.
Where are finished? Are you finished? Kaushik, you will be reading out the answer that you have written, okay? Magmay, from where are you copying? Huh? Whose book is that now? Why your book has gone behind? I'll throw you out, I'm telling you. I'm encouraging everybody to think, not copy from one person to another. Yes, Gufran, that is the right thing to do. As soon as you finish, close the book and sit. Don't help anyone around. Nobody wants to use their brain. Kaushik, I'm waiting for your answer. Come on, quick. Hurry up. Hurry up. Come on, in your own words. अच्छे handwriting में यहाँ भी होगा ना, यहाँ भी होगा. This is what I will do. Okay, listen to the answer now. Kaushik is reading. Come on.
The cord of the wire do not flow because the electricity level of the wire.
Resistivity.
Resistance of the wire, the cord is low as compared to the resistance of the metal, which is used for
So write it in two separate points, no, instead of writing such a big sentence. Write for cord separately, write the resistance for the heating element separately. So it's correct, but a better way of writing. Who can read? Who wants to read their answer? Where are you finished? Written it on the book. Have you written? Okay. Question number 2. What are they asking? Compute the heat generated. So what is given to us? What we have to find. Write down all the things, whatever is given. I'm going to ask you. Don't be too surprised. Okay. Charge is given. Alphabet will be what?
Q.
Very good. Compute the heat which is generated,
Heat generated.
okay, while transferring 9600 coulomb of charge. Time is 1 hour. You have potential difference of 50 volts. Okay, what alphabet shall we write here?
Q.
Q. Okay, I have to find out H. Look at the formulas. What can we use? You can't use anything.
No, ma'am, we can. IT.
Is there any direct formula?
No, ma'am.
What should we find out?
BQ by T.
Ah, you can use this. See here. Here. Q is equal to IP because Q is given to us.
Yes, ma'am.
Using this, you can find out I is equal to Q upon T.
Yes, ma'am.
If you know I, then you can
And
substitute.
what is the time, but
3,800 seconds.
Okay. So H is equal to I square R3. Or you can also use V I T.
It's in decimals.
Yes.
I is in decimal.
See, even for this I, no children. Here, this is. For this I, don't do any calculation here. Don't do any calculation. Just you put it as Q upon T here.
130. Okay.
Then it will cancel out.
Okay.
Not 23.
I,
I mean, heat 133.3. 133.3.
It's a very big number.
Yes.
133. X.
no.
I didn't know.
It's a big number. So you will have so many zeros.
4, 8.
Right, you're right. How many zeros?
5.
Okay, very good. Take it into 10 raised to power of 6. How much will it be?
That is power of 5. Oh, 4 by 8. Into 10
Unit?
I to use
What is the confusion? They have given 1 hour.
Ma'am, 4.8 into 10 to the power 6. वही तो किया
नहीं किया है, नहीं किया है।
The power of 5, or you can write it as 4.8 into 10 raised to the power of 6.
Time to use it.
Yeah. See, that is why I said. Yes. Yes. So the T part of it is getting cancelled out. That's why I said it is very easy. So that I said easy method of doing it.
Now what's the answer? 4.8. अंदर